Hey everyone, welcome to This Explainer. Today, we're diving into a massive, fundamental shift that's happening right now in the software world. We are looking at the rapid evolution from casual, one-off AI chatting to building fully structured, production-ready autonomous software agents. And to really make sense of this transition, we're going to use a sleek, cyberpunk-inspired blueprint to guide us from the world of AI video generation directly into the architecture of enterprise coding agents. Let's get right into it. To understand why software agents need standardization in the first place, let's look at how we used to interact with generative AI. We'd start with a messy, generic prompt like, make a cool sci-fi video with a robot. Now, if you've ever played with early AI video generators, you know exactly what happens. A prompt like this usually yields a chaotic mess of melting geometry and, extra fingers. It's a total black box. You have absolutely no idea what the AI is actually going to render.
But this brilliantly illustrates how structure changes absolutely everything. Think of this as a breakdown and fill-in-the-blanks master prompt. Instead of guessing, you define exact parameters. So instead of just a robot, your subject is a glowing robotic humanoid. Your action is walking slowly down a hallway. The setting is a sterile spaceship bathed in cold volumetric blue lighting, captured with a low-angle tracking camera, styled as a 3D Unreal Engine 5 render, and finalized with tech specs like 8K cinematic depth of field. This precise breakdown guarantees predictable, stunning results every single time.
So the crucial point here is that structure creates predictability. Let's move from the world of video generation to the world of enterprise code and ask ourselves a really vital question. If this 7-part formula is the blueprint for predictable AI video, how can we apply this exact same highly structured philosophy to software agents? How do we take a generic prompt and turn it into a reliable, autonomous coding system?
Part 1. Beyond prompts, structured agents.
Right now, there's a massive problem in the AI development space. We have incredibly smart, capable agents reviewing pull requests and generating code, but they're basically isolated black box scripts living locally on a single developer's laptop. There's no visibility. The difference between a fragile prompt I run sometimes and a robust agent my team depends on is entirely about infrastructure. Scaling requires a defined interface, a persistent place for it to live, and the infrastructure to run it reliably every single time.
Part 2. Setting the scene, context, and conventions. Let's start mapping our video blueprint to our software agents. Think back to the setting and style of our video prompt, the sterile ship or the dense megacity. In the software world, AI agents also need to know the specific environment they're operating in. Enter agents.md. Just like human developers rely on a README file, AI agents now rely on agents.md. It's a simple, open format that provides dedicated instructions, like how to run the dev server, or the fact that your project uses strict TypeScript and single quotes. Supported by over 60,000 open-source projects, this file gives coding agents precise project guidance without cluttering up the human documentation. We're also seeing this standardized at the API level. OpenAI is standardizing this context gathering with what they call skills. A skill is essentially a package bundle containing a skill.md file for the name and description alongside repeatable scripts, Python helpers, and asset templates. It bundles everything an agent needs to execute code in a sandbox environment, keeping the context perfectly contained. It's like a perfectly wrapped care package for your agent. Part 3. Subject and action. Goose recipes. In our video prompt, we define the subject and action, the robotic humanoid walking down the hallway. For an AI agent, the subject and action define its core behaviors, its system instructions, and its default prompts. And this brings us to Goose. Goose is an open-source AI agent framework created at Block and now hosted by the Agentic AI Foundation. What makes Goose totally revolutionary is how it defines agents. Instead of writing hundreds of lines of complex boilerplate code, Goose allows you to define an agent entirely in declarative YAML. It's readable, it's portable, and it is incredibly fast to deploy. At the heart of this is the Goose recipe YAML file. With just this single file, you define the system instructions, the user inputs, which actually become typed parameters, and even a structured output schema. It allows you to bring your own agent into production seamlessly. You define the exact behavior of your agent without writing any heavy SDK code. It's the whole shebang in one place.
Part 4. Camera and lighting, model context protocol.
In a video, camera and lighting dictate how a scene is captured and illuminated. For an AI agent, this translates to how it sees data and touches external systems. This is governed by the Model Context Protocol, or MCP, Guys, MCP is an absolute game changer. It's a stateful, open standard protocol that connects AI models to external data sources and executable tools. Think of MCP as the universal API for agents. It literally gives your language model the hands and eyes it needs to interact with your local files, pull records from a PostgreSQL database, or fetch data live from the web.
MCP operates using 3 core server primitives. First up, tools. These are executable functions that let the AI perform actions, like querying a database. Second, resources. These provide contextual data, like reading a log file or checking a database schema. And third, prompts, which are basically reusable templates that help structure the interaction.
And this is a highly dynamic lifecycle. An AI client can continually discover what a server can do. It can literally just ask, hey, what tools do you have, using a tool/list command. It retrieves templates, and then it can actually trigger those external actions. This means an AI application can adapt to brand new functionalities on the fly, right in the middle of a conversation.
But what happens after a tool is called? When an MCP tool executes, it doesn't just spit back some messy paragraph of text. It returns a rich content array that can include text, images, or direct resources. This provides structured, actionable data that the large language model can instantly ingest and reason about without getting confused by bad formatting.
Finally, Part 5, Tech Specs and Rendering. The Guild Control Plane.
We've reached the technical specs and rendering. In video production, this is your rendering engine outputting 4K resolution at 60 frames per second. For agents, this is the control plane. And that is exactly what Guild.ai provides. Guild acts as the platform layer and control plane for your agents. It solves that massive infrastructure problem we talked about at the beginning. It ensures that a brilliant agent built locally on a developer's laptop can actually be securely published to an agent hub, discovered by colleagues, and reliably used by the entire organization. So, how do all these pieces actually fit together? Well, Guild runs Goose recipes natively. If you push your goose recipe.yaml to Guild, it performs strict build time validation. It checks your template variables and schemas before the agent ever even runs, completely preventing those annoying silent failures in production. It then derives typed input and output contracts and spins up a fully sandbox, secure runtime environment.
And to connect it to the real world, you just drop in a guild.yaml file. By simply declaring your dependencies, like say a GitHub integration to pull repos or a connection to a shared research subagent, your agent is instantly wired into your enterprise stack. It can even use built-in UI tools to stop and ask a human for clarification. And get this, all of that happens without you having to write a single line of complex TypeScript.
So look at your own AI workflows right now and ask yourself, is your agent just a fragile, isolated prompt living on someone's laptop? Or are you ready to implement these open standards like agents.md, Goose, and the Model Context Protocol to build a truly scalable, production-ready, autonomous system? The cyberpunk blueprint is quite literally in your hands. So, what are you going to build?